Hello, everyone. Welcome back. So today we'll talk about test-driven development. Okay, what is test-driven development? It's just the concept or the paradigm of before you write any production code, you should test it. You should write a test that should fail before you even write the main function or write the main function. So there are a couple of there are three types of test-driven development tests. We have unit testing, we have integration, and we have end-to-end. But today we'll be talking about unit testing. Okay. So by the end of today, you would understand what unit testing is. You will set up, we are going to set up Jest correctly because of course, we are using JavaScript. So Jest is a framework, a library for testing. So we'll write our first real test and then we'll avoid the test is undefined error. Okay. So now you'll be thinking like a professional developer at the end of this. You get to understand why we should use unit testing, why should we should use test-driven development, why should we test our programs even before we write them. I believe you have actually you have when you have developed some applications, and when you go back to make some changes, then you make some changes, your application will break. You'll be wondering, it has happened to me a lot. All right. So now the thing is that most of us think that we should write our code before testing. And if you watch it, when you write your code before testing and you have an error, it's actually hard to figure out where the error is coming from. But if you have written some tests for your function, for your code, okay, you actually get to catch these errors, them, and you'll be more confident to push your code, okay? So what are the core concepts? Unit testing is the process of testing the smallest independent piece of a code in isolation to ensure it behaves exactly as expected. And most especially, when we talk about when we talk about the smallest independent piece, we're talking about a function. The smallest unit of our program is a function. So we are going to be testing our functions in isolation to ensure that it behaves exactly as we expected. So a unit test is typically a function, could be a method, and it could be a small module. All right, it could be a small module that you wrote. So unit testing is equal to testing the smallest piece of code. That is your function in isolation. So let's assume now you wrote a function called adder. The adder function has numbers and return their sum. So that is a function you can test. Okay, and you must test that function in isolation. You're not going to be testing the adder function with the subtraction function. No, you're not going to be doing that. You'll be testing your function in isolation. So look at this function now. This function is add. So it returns a plus b. It takes in a and b as parameters and it returns a plus b. So normally we could just write this and we think that, oh, after writing it, we just test it and we should, after that, before you write this function, you should actually write the unit test. This is the unit test. Okay, so the here now, when you write this test and run it, if you have not written the add function, it's going to fail. So then you will now know, oh, I need to go and write this function. This function does not exist. And again, if you write the function and 2 plus 2 does not give you 3, that means it's an error. Okay, so we are going to see more of this. These are the functions that come with Jest. We're going to take a look. We're going to see them in real action. So the key rule here is this: a unit test should not call APIs, it should not call connect to database, all right? It should not depend on other functions. We have what we call integration test. So integration test is a test that actually connects or combine or integrate two or more functions. Do you understand? But unit test works in isolation. It's just one unit, one function at a time. So it should be fast, it should be isolated, and it should be very, very predictable. All right. So unit test should be very fast, isolated, and predictable. So when testing a unit, okay, you remove all dependencies. Your function should not depend on anything. All right. You control the inputs, you verify the outputs. Okay. And then this is what makes it fast, reliable, and predictable. Okay. We have been talking too much. So let's get into doing some real example. So look at this. we have this function, get user balance. And when we say get user balance, uh, we are taking the user ID. And look at you, we are saying database.get user ID. You can see now that this particular get user balance function is depending on database.get user function. So this is not unit testing. It has an external dependency. It is also calling another function. Database.getUser is another function or method from this database module or whatever it is, whatever it is. So you can see that it is not isolated. Okay, it is not isolated. It has some external dependency. It depends on the database object or the database module. It's hard to test. It's not unit test. This is not, it's not testing a unit of your program. If you can see now, this function get user balance, when you call this function, it's also calling another function, get user from the database object or module. You see, it is not isolated. It is hard to test. It depends on the database. It is also slow and unreliable because if the get user function does not work? Okay, so good test is this. Get user balance. It will take the user object and return user.balance. This is a unit test. This is a very good testable code. So it doesn't, when you now run this, don't worry, we are going to do some of this, the test and expect and all these things. You're going to see more of it. So here we are saying this test returns the correct balance, and then we are creating the user object and we are passing it to this get user balance function. Okay, so this is pure unit testing. We are only testing get user balance. Get user balance does not depend on any other function. Okay, so now let us go and set up our Jest. Let us go and install Jest. So first of all, you have to make sure that the project you're working on, the folder, whatever it is a Node project. It's a Node.js project. So you have to initialize it. Okay, so you create your folder, you initialize it by init. Of course, you know this now. Initialize it. Okay, then you install Jest. Okay, so npm install dash dash save hyphen dev. So here we are actually saving this as a dev dependency. Okay, and then you will add your script. Now, the thing is that for me, I am using ES module. I am not using CommonJS. Okay, I am not using CommonJS. So let me show you exactly what I'm going to do here. So I will go to this folder. Okay, so um, okay, so this is what I'm going to do. I have this folder that I called unit testing. Okay, so okay, this is what I'm going to, inside of it, I am going to create another folder. I'll create another folder. I will call it um um I'll call it the other. I'll call it other. Okay, I'll call it other. So I'm going to open this other, okay, with Visual Studio Code. I'm going to open it with Visual Studio Code. Now, this is an empty folder. It is not initialized as a Node.js, okay? So what am I going to do? I would open a terminal. I will initialize it. So npm init y. Then once I initialize it, it will create the package.json file for me. But I will go to the package.json because I am using module, ES module. So I will change this into type instead of from CommonJS to module. Okay. Then this is the first thing. Then the second thing for me is to install Jest. So basically, you can go to the Jest website to their documentation. So this is the documentation, jestjs.io documentation. So go to the get started. So you can see here, if you're using npm, you can just npm install. So I'll click on it. I will select it. I would copy it. Then I'll go back to my I'll come here and then I will just paste it. So I'm installing it as a development. Okay. So while it is coming up, there's something I want to show you. definitely normally we are going to add the test script, but you can see what I have here. The normal thing is to say jest. The test, it will be jest. All right. But because of jest uses common JS, I don't want to use common JS. So that is why I now have this extra thing. So node hyphen experimental hyphen VM hyphen modules. Then where is it going to get it? It's going to get it from node modules, jest bin, jest.js. Then I will still add this watch all. Okay. So now let's see if my jest is still installing. My jest is still installing. So while it is installing, this is what I'm going to do. So if you take a look at what we have here, just while it is installing, we can still do this. Okay. So look at what I'm going to do here. Like I said, normally we could just do the test script should just be just like this, just dash dash watch all, so that whenever we make changes to our whenever we make changes to our just of we make changes to our program, it will run it automatically even without us. Once we save the file, it will run it. But now because I am using ES module, all right. If you are not using ES module, no problem. You just this is just okay. All right, but the type should be common JS. But for me, I use ES module. So what am I going to do? I am going to the test script is going to be node hyphen experimental hyphen VM hyphen modules, then space node underscore modules / jest / bin / jest.js, then sorry, watch. Oh, okay. So I believe our jest has so it is installed correctly. So make sure that you have this. Let me cross check. Node experimental VM modules, node module, just all right. Okay, so now this is correct. We are here. So if I go on now and run, if I go on now and run npm tests, okay, all right. So okay, so it is cool. All right. So if I say npm run test. Okay. Now it's not running anything because we don't have any file for it to run. Okay. So now what we need to do now is to create a folder, all right, for where all of our tests will be coming. So, but we are coming to that later on. So now step 4 is to create a folder, all right. Create a folder, or we already have a folder, so we can just create a function, a file, a JS file, and this .test file. Because when you run npm, when you say npm run test, it's going to look for a test folder or a .test.js file. So, but for me, I'm making the habit of having all my tests in the test folder. Then inside of it, I will now have, let me call it ada.test.js. Okay. All right. So if I go on now and run this npm run test again, let's see what it gives us. It's going to find a test folder and then a .test.js file. Of course, we don't have anything inside. So now, what did I say about? I talked about having, okay. So now, so let us write, before we write our other function, let us write a test. I could say, I could just say test. I could say test, and I'll say should return the sum of two numbers. Okay. Now, it takes an arrow function here, a callback function, and then we should not go for expect. I'm expecting sum of 2 and 3 to be 5. Now, but you can see it's crazy. Do I have any, okay, no, I'll call it adder. The thing is this, do I have any function called adder so far? I don't have it. So when I run this code now, I think something is wrong. Something is wrong. Okay, okay. So I think something is wrong with with what I have here. Let me go back. Okay, let me take this. I think I'm having something wrong there. Just watch what I'm doing. So I think I'm having, okay. So let me run this again. Okay, sorry guys. The issue I was having is because my test script here was just saying node without this. Okay, so there was a conflict. All right. So now, like I said, if you run npm, if you say npm run test, you can see it has run this test now, and look at what it's telling us. It's telling us that it runs adder.test.js. It should return the sum of two numbers, but it says Ada is not, it failed. Okay, it failed. It failed. Okay, so now it's failing because right here we do not have the other function. The other function is not available. All right, so now let's go on and add and write the other function. No, not inside test. So adder.js. All right, so we are exporting maybe default function, export default function. It takes A and B, and then it returns A plus B. Okay, now we have the other function. So let's go and import it here. So if we import it, all right, so we have it. Now this is going to reload because of the watch. You can see that it has passed. Because now the first time it didn't see the other function. So you can see that we have written a test because we were expecting to have another function. So we have first of all written a test that should fail if we don't have another function. Now it has passed now. Everything has passed now. So this is our first test. Okay, so we have installed we have created the test folder, and we have the adder.test.js. So before we add anything here, we should actually come here and write if tells that we fail. Now this thing is called the red green refactor. So now you can see that the first test we had was red. So it failed. We should write a test function that fails. Then we'll now write the code that will make it pass. And then whenever we refactor, it shouldn't also fail. All right. So now we have done this. We have created our folder and we have written our first test. So the important thing is this. Never you run node sum.test.js. No, it won't work. You're not running node sum. No, you're not calling the sum.test.js function. No, you should use npm test. And most especially have the script. All right, have the script. Okay. All right. So now this is a simple function here, and then this is exactly what we have done. So in this case, we have the test function and the expect. That is the two functions that we have seen from Jest, the test and the expect. So let's explain more about them. So the test function defines a test case. What case are you trying to test? What behavior of your function do you want to test? It's a single behavior that will be tested with the test. So you give it a description, and then it takes a callback function that will take your test logic. Okay, then the expect checks the result, and then expect value dot to be. Now, this to be is what we call Jest matchers. We'll talk about them later on. So we say we expect a particular value to be what we the expected value. So now we have common matchers like to be. So we're expecting 2 plus 2 to be exact 4. That is an exact match. When we have this array 1 and 2, we expect this array to be 1 and 2. So this is deep equality, but don't worry, we'll go more into it. You can also expect a value to be truthy. Okay, so now there's something we call the the triple A pattern. Now, first of all, you should arrange, then you act, you assert. You arrange, you act, you assert. How does this work? Now look at this function. Look at this function. So let's go back to our test function and rewrite it. So now, first of all, we should arrange. So what are we arranging? We are arranging the variables. Say A is equal to 8, and then B is equal to 10. All right, so we have arranged. So let me have a comment here. This is arrange. All right. Now, after you have arranged, you will now act. Let us act. So we are now going to call our function and save the results. So this is result equal to, this is better, result equal to, let us call our other function and give it A and B, right? So then let us assert. So we are now going to use the expect function. We are expecting our result to be exactly, so exact match. We are expecting our result. 10 plus 8 is what? 18. We are expecting it to be 18. All right. So we can take this one out now. So this is more organized, more professional. You arrange, you act, and you assert. So if we go back down now, you can see that our function has even dictated the changes we made. And of course, it also passed. All right, it passed. So you can see that even when you go now and make some changes. So I don't know, have you been writing your code before? After you made some changes, your code will break. It has happened to me a lot of times. Now, just imagine that we come back here and just make some changes. Let's just say const c equals to 9. Okay, you can see our function is running. Our test function is running. Look at it. It is running. And voila, it didn't break our test. We made some changes, but it didn't break our test. So, but if we come back now and say return A plus B plus C, let us see. It is going to break. You see, it has failed. Look at it, it has failed. Because we made some extra changes here. This is called refactoring. Now we have done red, green, red. Now we just refactored our code. Now you can see that we have refactored our code and our tests have run. And you can see that our test was expecting 18, but it got 27. So there is an issue. So our test has failed. All right. So this will not tell you, oh, go and fix it. Before you even push this into production, all right, before you deploy your code, you will have to fix your test for your test to work out. Okay. So that we are coming back to that. Okay. So if you have a function called the withdraw function, okay, this withdraw function, okay, let me go and write it. Let's write this function. Okay. Let's go and write, I will write a function. I'll call it withdraw.js. But before I go on, I have to write a test. Withdraw.test.js. So before we write, if I go back to our slide, before we should write this function, we need to write a test. We need to write the test first. Before you even write your function, you should write your test first. So now let us go and write this test. Where the test description is it will withdraw money correctly. Okay, so we expect if you withdraw 10,000, if you withdraw 1,000, if your balance is 1,000 and you withdraw 200, it should give us 800. So let's go and write the test first. So, but first of all, I am just going to change this so that our test doesn't keep work. Okay, now let's go to withdraw test.js. So I am saying test, all right, test, the description should be should withdraw correctly. Okay, basically, let me make it should withdraw correctly. I can say balance minus, okay, I can do this. Just to make it descriptive, balance minus withdrawal, balance minus amount. All right, balance minus amount should give us, it should give us, okay, let's say balance, let's say I do something like this, balance of 1,000 minus amount of 200 should give us what? 800. All right, so this is my description. Then my callback function here is, first of all, I would arrange. All right, so I will say const balance is equal to 1,000, and then const amount to withdraw is equal to 200. All right, so now this is my array. Let me act. I will now say const, result is equal to withdrawal. Withdraw. Remember, I've not written this function. This function does not exist, so but we expect it to exist. So I'll say withdraw balance minus amount. Okay, so this gives us what? This is the acting, and then let us assert. So I will now say I expect that result would be I expect result to be 800. Now look at what is happening. This is going to fail. We have written our test. Look at it. It has failed. One failed, one passed. Okay, which one failed? The withdraw. Look at it. This is one. It said withdraw is not defined. So you can see that we have first of all written our test. We expect that we should have the withdraw function or any other function, deposit, whatever it is. Now, the first step we need to do is to let's go to the withdraw and write a function. So I'm also going to export maybe default. Okay, because this is the only function I'm going to have here. Function, I'll call it withdraw. Withdraw will take balance and the amount, and then it will return balance minus amount. All right, now we have written this function. Let's go to the withdraw test, and then let us import this function. And once we have done that, look at our test is going to pass now. You can see it has passed. So it has passed. So you can see red, green, refactor. Red, green, refactor. Red, we'll write a test that will fail. Then we'll now write code that will pass that test. And then that is, even if we refactor, nothing will happen. All right. So we have done this now. Okay. So you can see now that we have written the test first before writing the. All right. Now we can also check for That we'll come back to this. I will come back to this. Okay. Now, we can also check for if the withdrawal is insufficient. Okay. Okay, let's just do this. So now we could write another test inside of here. We could write another test, and then let me just copy this. I'm writing another test, but I would say should throw an error, should throw an error if amount is greater than balance. So we don't want users to actually withdraw. So we say um, when we call this, we are going to say expect this. Okay, so we'll say to true. Okay, let me just to true instead. So we're going to have okay, so now let's come here. Balance is 1,000 and this is 2,000. When we do this, we expect that this will throw an error. We expect to say insufficient balance. That's what we are expecting. We are expecting this test to throw an error because balance amount cannot be greater than, you cannot withdraw more than your balance. Now you can see now that our test has failed. It has failed. So for us to fix this, let us go and let's go to our withdraw this thing and let's refactor our code. So we say if um, if amount is greater than balance, what do we want to do? We want to throw error insufficient balance. So let's see if everything works fine. Okay, it's still failing. Okay, it's still failing. Okay, so what did I have there? Throw new error. I'm so sorry. It should be throw new error, not throw. All right, my code is bad. It is throw new error. Okay, so if I go back now, you can see it's checking, and voila, everything. Okay, we still failed. It still failed, but let us see why it failed. Um, insufficient balance. Okay. Um, all right, you can see it's showing an error. Insufficient balance, insufficient. Okay, why is it failing? If amount is greater than balance, show new error, insufficient funds. All right. And our test says, okay. Sorry. This is what I'm supposed to do here. Um, it's not, this is, I'm supposed to call this withdraw here. It's not that result that, okay, sorry. This is what I'm supposed to do. So it's like this thing is not needed there. We still have some error. Where is it coming from? We expect this to throw insufficient balance. Okay. Is it because of, okay, coming. If amount is greater than balance, throw new error. Okay. Sorry, I am even somehow. If amount is greater than this true new error insufficient for return balance. Okay. And then test. We expect this. Okay. So I think it's from my code. So we expect this to be this. Still failing. Okay. So we are expecting now it's showing an error. We expect it to throw an error. So, but what if balance is not greater than? You, okay, so that's not okay. Mm. I think my code is wrong here. Choose error. Expect this. Okay. Okay, I think I was the problem here. All right, so we have we can see if it is supposed to throw an error. So but it was from my code. So let me try again because this expects a callback function. So that is why. All right, so this is returning something and this one is going to throw an error. So this is how it works. So you can see now that I wrote a test, all right, that is supposed to throw an error if the balance is greater than if the amount is greater than the balance. And by the way, we have finally we have refactored our code to actually do that. So we have written the test and then we have refactored our code. So edge cases. Now the thing is that there are something we call edge cases and normal cases. Normal cases is that when you have something like the other function, you're only saying 2 plus 3, 2 and 3, but you're not checking what if the user gives you something that is not what you're expecting. So normal cases is most developers, we just test the normal cases. We don't test edge cases. Now, in our other function, we are just testing 2 and 3, right? So look at our other function here. Where's our other function, our other test, we're only saying should return the sum of two numbers. What if the user gives us three numbers? What if they give us an array? What happens? So this is normal case, but we should do more than normal. We should test more than normal case. What if the user gives us 0, 0, or what if the user gives us a negative number? So we should also test things like that. Okay. So we should also test for invalid case. What if the user gives us invalid input? We should throw an error. Okay. So now let's dig deep into what we mean by edge cases and normal cases. Edge cases are inputs or scenarios that they are the boundaries of expected behavior. No, when you're writing your code, you're writing the code, you expect the user will just follow, do exactly what you're writing. No, users can come with something crazy. So they are unusual, extreme, or invalid. They often reveal hidden bugs. So if you have another function and your normal case you're testing, it should return two numbers. What if the user gives you three numbers? What if the user gives you five numbers? Okay, what if the user gives you a negative number? What happens? So edge cases, if normal cases are what users usually do, edge cases are what users might try accidentally or maliciously. Somebody might want to attack your code, your program. Somebody might accidentally do something wrong. Okay. Boundary cases are like 0 and -1 for very large numbers. So what if you're expecting an array, okay, and the user gives you an empty array, or you're expecting a string, they give you an empty string? What happens? So you should test for all these things too. So what of invalid inputs? You're expecting a user gives you six password that is 6 digits, and the user is giving you just four. So these are invalid inputs. So invalid inputs are wrong types, missing required fields. You're expecting in our other function, you might be expecting integers, and the user gives you, okay, what happens here? Let's do something now. Let's say I'm calling this function instead of it to be, okay, instead of giving an integer, I am doing this. What happens to it? You see, it has failed. It failed because 18 and 810 is not the same thing. So you should also write um, 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 code that will check for this kind of things. All right. You should write code that will check for this kind of things. Okay. So out of range values and stuff like that. So what is invalid case? Invalid case is when the input violates the rules your function expects. Example is passing a string instead of a number. You just saw it now. Okay. Now, negative values we are not allowed. You might not be allowing negative values. If you want to take somebody's age, you will not allow negative values. What if the user does not give you the required parameter? So let's go back. In this case, now we are expecting two numbers, right? And then the user did not give us, only gave us just one. What happens to our test? Let's see. What happens to your function? So we should also test things like this because it has failed. So you should write programs that would also, not just the normal cases, edge cases, invalid cases. Okay, so why developers fail, most developers actually test happy part, the normal inputs. They just assume that everything works well. Assume users will always behave correctly. No, they don't. But in real systems, users make mistakes, APIs send bad data, attackers send malicious inputs. That's why invalid cases are critical. You should test for edge cases. You should test for cases that are at the boundaries of your test. So now let's take a look at our withdrawal function, The business rule states that you cannot withdraw more than your balance. You can see in our normal, when we wrote this withdrawal test, the first test we wrote was just testing the normal case. But later on, we now checked if the balance is less than the amount. So this is edge case, invalid case. That's what we did here. So the business rule states that withdrawal cannot be more than your balance. Okay, so that is where we added this edge case here. Okay, so the normal case will only test for when balance is greater than withdrawal. All right, but edge case over withdrawal, edge case, invalid cases are like when you're trying to withdraw more than what you have. All right, you have 100 naira, you're trying to withdraw 200 naira. So your case, your test should check all these things. So why does this matter? It prevents users from going negative. You cannot allow your balance, the amount user wants to withdraw to be more than the balance. So these are invalid cases. They are edge cases, not the normal case. The normal case is like, oh, the user has 1,000, they want to withdraw 200. What happens if the user just has only 100 naira and they want to withdraw 200? You see, this makes you a professional developer. If you start writing unit tests or using test-driven development parallel, if you start using it, you would have less errors in your production code. So this protects financial integrity very much, very important in fintech apps. So what if the user gives you a negative number that they want to withdraw? You should throw an error. You should throw an error. Negative numbers cannot be allowed as an amount, as the amount. So without it, someone could exploit your system. So these are the cases we should check. All right. What if they give you this is the wrong type? This is a valid case. You should also check if the user gives you a wrong type. Instead of an integer or a number, they are giving you a string. All right. So this prevents type-related bugs. All right. So how to handle invalid cases in code? So you must validate input explicitly. So look at the improved code. Our withdrawal, this is our withdrawal function now. First of all, checks the type of balance and also checks the type of amount. It will throw new error and say invalid input type. So then if amount is less than or equal to 0, it will throw amount must be greater than 0. You can see we are now checking the invalid cases. But before we even do this, we should have written the test. You should write tests that check against amount being less than or equal to 0. You should write tests that check if the type of balance or the type of amount is not a number. You should also write tests that you check if the amount is greater than balance, and you can see, so this is the full code. So here we are checking the type of balance, the type of data for balance and amount. We are checking if amount is less than or equal to 0, and we're also checking if the amount is greater than balance. And then if none of these things are bad, then we return balance minus amount. Okay, so this is your assignment. Build and test these. Create an add function, create a subtract function, then create a withdraw function, and then test for normal cases, test for edge cases, and test for error cases. Okay. So if you have any question, please reach out, come to the WhatsApp platform, come to the community. Let's talk about it. Come and ask your questions. Okay. And thank you very much. I will see you in the next class.